Welcome to Study Loop.
Problem 8.43, we have a 12-gram bullet hitting a ballistic pendulum, 6 kilograms. It's going 380 meters per second immediately before the collision. The pendulum is suspended from a 70-centimeter cord. And the first thing we want to find is through what height does the pendulum move after the bullet hits it? It swings backward. The second thing we want to find is the initial kinetic energy of the bullet before the impact. And the third thing is, what is the total kinetic energy right before or right after the impact, but before the pendulum has started swinging and turning some of that kinetic energy into potential energy, and eventually it gets to the top of its swing and it all becomes potential energy. So, if, like I just said, if we want to use the conservation of energy to figure out how high the pendulum goes, then we need to know what its kinetic energy is, and in order to do that, we need its speed, for which we can use the conservation of momentum. So the initial momentum just consists of the bullet moving, and then afterwards the bullet lodges into the pendulum, and they both start moving together. So we have the combined mass, pendulum, and bullet. And for the sake of brevity, we'll call the speed here the speed of the pendulum, even though the bullet is also lodged in it. So the speed of the pendulum is going to be equal to this ratio of the masses of the things that are moving before and after the collision times the initial speed of the bullet. And now this works out to be 0.758 meters per second. And then we use the conservation of energy. So 1/2 the mass of the combined object, b squared, equals the mass of the combined object again, GH. So it doesn't matter what the masses of the objects were. And we find that our H here is the square of the speed immediately after it starts moving, divided by 2g. And this is 2.93 centimeters. So not especially high. For part B, we want what was the kinetic energy of the bullet to begin with. And this is fairly simple. 1/2 times the mass of the bullet times the speed of the bullet squared. And this ends up being 866 joules. Now, immediately after the collision, we need to know what the total energy is of the bullet and pendulum moving together. And because this collision is totally inelastic, or it's inelastic at all, but especially being totally inelastic, we expect that there's going to be a loss of kinetic energy because some of it gets dissipated in deforming the material of the pendulum, and it gets turned into heat and sound and all sorts of things. We might call this K initial, and we might call this K final. Although it's sort of more like K intermediate, but that would also be an I, so yeah. So here we have the total mass of both objects and the speed of the pendulum with the bullet in it squared. We found before is this 0.758 meters per second. And this works out to be 1.73 joules. So you can see quite a lot of energy got lost in the inelastic collision where the bullet was lodging into the pendulum. Which, again, is sort of what you would expect to happen because it's a totally inelastic collision, and so a lot of the energy is going to go somewhere else, being converted into different forms.